This lecture will cover method parameters. We are going to talk about how to define method params, passing params by value, and how to pass params in code. To obtain more information, search the internet for passing information to a method in Java. A method is the same as a procedure. It is a short, named group of commands for completing a specific task. You have subroutines and functions. Subroutines do something, and functions do something along with returning a value. Here is the syntax for a method: the return data type, method name, and optional parameters. This has its own set of curly brackets as well. Use the void data type when the method does not return a result. Use any other data type to define the value that is passed back from the method. Be sure to put the return at the end of the method, since execution of the method will stop as soon as the return is encountered. The parentheses after the method name contain the parameter name. These parameters can be values or variables passed into the method or by a calling method. You must include the data type and the variable for each parameter. If you have more than one parameter, separate multiples by using the comma as shown here on the screen. Here is an example of passing parameters into a function. In this case, we are passing 5 and 10. When they are used in the add to values method, the 5 is value 1 and the 10 is value 2. This slide shows how to use variables instead of hard-coding values. Obviously, you can mix and match them. The names in the calling method do not have to match the names in the called method as shown on the screen. Be sure to use meaningful variable names. Parameters can be passed in two ways in most languages: by value and by reference. When you pass a value, a copy of the original variable is sent to the method being called. Any changes in the called method are made to the copy and the original is unaffected. This slide shows how the pass by value works. Notice how pass by value method changes the copy to 42, but when it returns to the main method, the original is still 0. In Java, all variables are passed by value. Java does not have a pass by reference. Let's review variable memory allocation. In Java, we have simple data types such as short and long, float, and character, and we have complex data types such as arrays, structures, and classes. With simple data type declaration, Java reserves one block of memory that cannot be used for anything else. The data type determines the amount of memory reserved for the variable. The smallest is a character, which is 1 byte. The larger the value, the more space it takes up. Here are sizes for simple data types. You can think of this like an Excel spreadsheet, and each byte is one cell. See the sizes of value 1, value 2, and value 3 on the screen. Complex data types are different from simple data types in memory allocation. Complex data types are arrays, strings, structures, and classes. When a complex data type is declared, 2 pieces of memory are allocated. Why? Because memory for variables can be allocated from 2 different places. For small fixed-size variables that are made up of simple data types, memory from the stack is used. For larger, non-fixed-sized variables, those are the complex data types, memory from the heap is used. Stack memory is calculated at compile time. The program knows the space required for allocation, and the memory is allocated all at once when the program starts. This is more efficient. The heap memory is for complex data types, since the amount of memory required is unknown until program execution. The program does not know the size of the data read from a file until the program is executing. As the program executes, a special call is made to the operating system when more heap memory is required. Here is a slide recapping the definitions of stack memory and heap memory. A small portion of stack memory is allocated and a large portion of heap memory is allocated for complex data types. A reference or pointer variable is used in stack memory. This stores the address of the larger heap memory that was allocated, as shown on the screen. We are learning this so we can solve business problems using the tools we have available along with understanding the limitation of our tools. This is why we found the minimum and maximum values for data types in Homework 1. Complex data types are not passed by reference since they are composed of two parts. The actual data is in heap memory and the reference to the data is in stack memory. The reference part of the data is passed by value, and this means any changes made by the called method to the data are permanent. If we declare an original variable, buffer, in the main method and pass it into another method as copy of reference to buffer data, it will copy the reference but point to the location in heap memory as shown here. Look at the change values example. Take a moment and download the code and try to execute this for yourself. The previous slide shows how the data values are not passed by reference since the address portion of the complex data type variable is passed by value. Once the call method allocates and assigns a new block of memory, the new memory reference is saved as a copy of the variable. The original variable, from this time on, is unaffected by any changes to the new memory. Let's look at this example that copies the variable. Refer to array change code and try to execute this program on your own. Here is a visual of what happened for memory allocation in the previous slide. We need to understand how this works in order to properly solve problems in Java. The simple data type can never be passed by reference and cannot be changed in the called method. Array values can be changed. Array sizes cannot be changed in a called method. Space must be allocated for a new array, then the values must be copied from the original array. The new array is returned to the calling method and must be assigned to the original array variable. Also, strings cannot be changed in a called method. Let's take a moment to review the questions on the screen. Let's take a moment to review the answers on the screen. To summarize this lecture, for complex variables, any changes to a variable made in a called method will affect the original variable as long as you do not change the size. Once you change the size in the called method, the changes will not affect the original variable in the called method. You know the size has changed because the complex data type variable will be on the left side of the assignment operator as shown in the examples on the screen. And this concludes our lecture. Thanks, and see you next time.